Alright class, hello, this is Miss Riggins with today's video on Arithmetic Series, which is in section 13.2. This is a very easy chapter, so this section is also going to continue with the easiness. But before we get started, I'd like to do some shout outs to people whose birthday we missed or are going to miss. So last week it was Lucy's birthday, so happy belated birthday, Lucy. And this week on Friday is, I believe, Kathy's birthday, and we won't be there to celebrate Kathy's birthday. So I'm going to do a very quick version of my birthday song for you two ladies, and I hope everyone else joins in when I sing it. Today is a special day. It's the day that everything will go your way. Today is the day that you were born. It's your birthday. Come on, rock on. It's your birthday. It's your birthday. It's your birthday. It's your birthday. You got a cake and some candles and some presents on your table. Why? Because it's your birthday. It's your birthday. It's your birthday. It's your birthday. Happy birthday. Okay. Still trying to keep the videos under 10 minutes, so I had to do the abbreviated version. But I hope you enjoyed your birthday, Lucy, and I hope you enjoy your birthday, Kathy. So let's get back to this very easy topic, arithmetic series. And an arithmetic series is basically a sum of so many terms of an arithmetic sequence. Okay. Before we start talking about that, let's take a look at the symbol for sum. The symbol for sum is the Greek capital letter of sigma. So it looks like a funny capital E, but that means addition. So whenever you see sigma in math that looks like this, capital sigma, then that means it's going to be a result of adding some things together. Well, what is it that you're adding? You're adding terms of a sequence. Okay, so in this case, we refer to the sum of n terms, and n can be any number from 1 to whatever, infinity. We're going to add the first term is usually I equals 1, the term A1, but it doesn't have to be. And the last term is n. And so this indicates that the sum is going to end at A sub n, which is the nth term of the sequence. And it's going to start at A sub I, which is, in this case, the first term of the sequence, but it can be actually any term. So they're going to say the summation of I, where AI is the arithmetic sequence. Okay, and how you calculate that is you take A1, which is the beginning term, and add it to A2, which is the next term, A3, all the way up to AN. And after you have finished adding all those terms up, those n terms up, then you have the sum, which is one number, S sub n. Okay? So it's very simple to understand, but let's take a look at an example. So let's say we have some value, some sequence, and that sequence can look something like, oops, sorry, summation of 2I, okay? And I is equal from 1 to 10. Well, that means, oops, let me not do that one, that's that, not equals. That means 2 times 1 plus 2 times 2 plus 2 times 3 all the way up to 2 times 10. Okay? And so we can compute this manually by just adding up the terms. 2 plus 4 plus 6 plus 8 plus, going all the way up to 20. And the resulting answer is our S sub 10. Okay? Because we've added up the first 10 terms of this sequence. Okay? So, of course, we can do this by brute force, but in math, we like to do patterns. So on your video assessment, you won't be able to use a graphing calculator, but you can use a little 4-function calculator. So make sure you bring a little 4-function calculator, because I don't want you to sit up here and add all of these on a 4-function calculator. I'm going to show you a trick, okay? And that trick involves a little story I want to tell. Now, the story involves the mathematician, famous mathematician Gauss. And Gauss was, when he was a little boy, I don't even know how much of truth this story is, but people have embellished it, and I'm probably going to paraphrase it and embellish it some more. But when Gauss was a little boy, he was bored at school, and his teacher was so frustrated because he was so bored, and he already finished his work. So she just told him, Gals, go stay in the corner and add up the numbers from 1 to 100. And she was shocked when he came back shortly. And he even told her the correct answer, which was 5,050. And the question is, how in the world did he do that so quickly? He didn't have a calculator. This was back in the day where they didn't even have calculators. So how in the world did he add them all up so quickly without, using a calculator? Well, Gauss was a very bright boy, and what he did is he noticed a pattern. So if we take a look at the numbers 1 through 100, if we take a look at the first 5 numbers, and let's take a look at the last 5 numbers, and then group them like this. So 1, 2, 3, 4, 5, then 100, 99, 98, 97, and 96. Well, one of the things that Gauss noticed is that the sum of the first and last number ended up being the sum of the second and the second to last number, and it ended up being the same as the sum of the third and the third to last number, and ended up being the same as the sum for the fourth and the fourth to last number. So he noticed a pattern in that all of these special sums added up to 101, 101, 101, 101. So the question is, how many 101s are there? Well, think about it. If he takes the first half of the 100 numbers, then he's basically adding 50 numbers, 50 pairs of numbers. So that's 50 pairs of 101. So to figure out the answer to the sum, instead of adding them all up individually, he takes 50 and multiplies it times 101, and that's how he gets 5,050. So we're going to use Gauss's method because it really works for any type situation, because it's simple to remember and to understand. So let's go back to our notes and let's take a look. So say we have a sum of n terms of an arithmetic sequence, and that's S of n. And if you remember, A sub n can be calculated by taking the first term and adding it to a multiple, an n minus 1 multiple of the common difference. And if we want to add the first in terms of the sequence, using Gauss's method, we take half the number of numbers that we're adding. So with Gauss's, we had to add the first 100 numbers, so we took a half of that to get the number of pairs. In our case, it was 50. And then we multiply that by the sum of the first and the last number, like we did with Gauss. But take a look. What if you can say, well, I don't know what the last term is. They just told me to add the first, 1,000 terms of the sequence, and I don't know what the 1,000th term is of the sequence. I know what the first term is, but I don't know what the 1,000th term. Well, that's what last week's video was, where you can replace a sub n with a sub 1 plus n minus 1 times d. So in other words, over here, we can say, oh, well, this is the same thing as this. So when I add a sub 1 with a sub n, I get a sub 1 plus a sub 1 plus n minus 1 times d, which ends up being this formula right here. So you have a way of calculating the nth sum, the sum of the nth term of the first n terms of the sequence by taking 2 times the multiple of the first term and adding it to the n minus 1 multiple of the common difference, and and multiplying that by a half times n. Of course, we can simplify it more, but to me, this is what I understand where we got this formula a little bit better. So that's how you find the sum of the series. So let's see if this works for the sums from 1 to 10. So 1 to 10, well, those are 10 numbers, so 1/2 of 10 is, of course, 5. And then I multiply that by the sum of the first number, which in my case was 2 for this situation. And then the last number, which was 20. Okay, so we get 22 times 5, and that is 110. Okay, so let's see, that's about it, and I hope you enjoy your day. Bye bye.